Hello everyone, what's up? We're going to continue with our AP Calculus AB cram series here, and now we're going to do the second derivative test with concavity, continuing with the graphing analyses. Okay, so what does it mean for concavity? So, graph with concave up looks like this, and something that's concave down looks something like this. So basically it has to do with the shape graph is forming, basically. Alright, so how could we determine concavity for when we're dealing with the second derivative? So when the second derivative is 0, at these x's, it will be our inflection points. So these inflection points, again, like crit values, this is where we'll test the second derivative for positivity or negativity. So if the second derivative is positive, that means it's concave up, and if the second derivative is negative, that's concave down. Put a D for down. Another thing that's important to know is a crit value, not a crit value, a point of inflection. Let's say this is the graph of f prime, and it would actually occur at where the derivative has those horizontal tan lines. So like right here at A, right here at B. Okay, so let's get to an example of the second derivative test. Let's use, let's use number 5. This example, we're looking for the points of inflection and concavity for f equals 1/2 x fourth plus 2x third. And right off the bat, let's take the derivatives. 2x cubed plus 6x squared. Then the third derivative we'll write down here, 6x squared plus 12x. And now we're going to set that equal to 0 to find our points of inflection. I'll get this 6x, x plus 2 equals 0, x equals 0, and -2. Alright, so now we plug in, we make these intervals again. See here in the middle, -2, 1, -1, 1. Let's do -3. Okay, so again, we're going to be plugging in these numbers for f double prime. When we do that, we go from -3. When f prime is -3, the x is -3. That would yield us a positive value. In -1, if that's the x for f double prime, we get a negative value. Again here, if we plugged in -1 to f prime, we get a negative. If we plugged in 1, we get a positive. And that means because f prime is negative between -2 to 0, so -2 to 0, this means f is concave down at that interval. F prime is positive like that at -infinity, because like we're going way beyond -2 from lower numbers to -2, but also from 0 to larger numbers, it's also positive. So we also put that down here. And that means for this, f is concave up for those intervals right here. Both of them, union sign, both of them. Okay, so now I think we're finished with that. We could also look for a relative extrema. We'll do this quick thing where a relative extrema of the graph of x plus 4 over x. Then when we take the first derivative, I'm going to go fast here. 1 minus 4x squared. I've already done this problem. Then now the second derivative is 8x3. Okay, so now we have the crits are plus minus 2 because don't want it to be 0. So then we go that. We have 2 over here, negative 2, that's negative 3, negative 1 is going to be 1, 2, 3. So then when we plug these in, go positive, minus, minus, positive. So we know that now relative extrema, so again this is going to be increasing, decreasing, decreasing, increasing. We have a relative max at the point of negative 2, so that increasing decrease. We have a relative min at 2 because of that decrease to increase. So rel min at 2 to the 4. Again, plug in the 2 to this, get 4. And then rel max at negative 2, negative 4. Because we have that increasing to decrease for max, we have that decreasing, increasing for min. Right? So that's the second derivative test.